Transmission media speed, whatever the data transmission method we are using, how the speed of transmission will be there will be dependent on these three things, that is a bandwidth, bit per second, and baud rate. First thing is bandwidth, the amount of data which can be transmitted on the media over a fixed amount of time, that is in seconds. It is measured on bits per second or baud rate. Okay, the amount of data we can transmit through the transmitter or a medium over a fixed amount of time, whatever the amount of time we are taking. See, if I am taking always the data, whatever the signal I am taking, if I am writing high, and it will be always converted into zeros and ones, 0 1 1 1 0, in this way 8 bit of data it will be converting in any of this information into bits. Okay, if I am transmitting a 8 bits per second, within 1 second I am transmitting 8 bit, then it will become a 8 bit per second or a baud rate of your transmission line. Okay, and bits per second, a measure of transmission speed, the number of bits which can be transmitted in a second, that is the bps, bits per second. If I am transmitting number of bits in 1 second, then that is your speed of transmission. Baud rate is a measure of how fast a change of state occurs. Change of state from, see, you will be having a data transmission in the form of bits, that is 0 1 1 0 1 1 0 1 1. In that way, binary number transmission will be done. Always you have to see that how the change from 0 to 1, how many times it is doing the change from 0 to 1 or 1 to 0, like changing from one value to another value, not with the same value. One to one is not a problem of transmission changes. That's why you can measure the baud rate if I am changing from 0 to 1 or 1 to 0. Change over from one value to another value. 0, normally how you will be representing in the form of waveform, 0 will be negative and 1 will be positive. Next 1 is there, next you will be having 0, next 1, next is 1 1 1, next 0 is there, next 1 1 is there. This changeover you have to see, this changeover from 1 to 0 and 0 to 1, you have to see. This is called as a baud rate. Okay, how many number of times you are going to see for one 1 second transmission, within 1 second of transmission, how many number of changes, this changeovers are there from 0 to 1 or 1 to 0, that will be giving you a baud rate. Receivers. A receiver is a collection of electronic components and circuits that accepts the transmitted message from the channel and converts it back into the form of understandable by humans. Whatever the electronic signals are used, means at the transmitter end you will be transmitting in the form of what? You will be transmitting in the form of actual message only. Whatever the this, voice message or another way you can take it as an written message, anything, video or audio, everything will be converted into electrical signals or optical signals or any other type of signals, that at the receiver end you can't read out the electrical signals, you can't read out or you can't hear the um, optical signals, that you can convert or you have to convert it into the message which can be readable or understandable by the human being, that you will be doing at the receiver end. Receivers contains the amplifiers, oscillators and mixers, tuned circuits and filters, and a demodulator or detector that recovers the original intelligence signal from the modulated carrier. Whatever the signal we are transmitting through the transmission line, you will be doing so many operations on that, so many process on that, like you will be converting it into electrical signal, converting it into optical signal. You can do modulation on that to maintain the quality of the signal. Everything you will be doing on the signal, that you can recover it by using these electronic circuits like amplifiers, oscillators, mixers, tuned circuits and filters, and a demodulator or detector, and that recovers the original intelligent signal from the modulated carrier. Transceivers. A transceiver is an electronic unit that incorporates circuit that both send and receive the signal. Like if I am taking two devices or two external devices where you will be transmitting the information from one end to another end, that will, here it will become a transmitter, here it will become a receiver. At the destination end it will be receiver. But sometimes you want to transfer the data from this end to this end also. At that time this will act as a transmitter and this will act as a receiver. That's why the both operations, that is transmitter operation and receiver operation, both operations operated at the same end or same device, is called as a transceiver. Transceiver, it is called as a transceiver. For example, you can take it as telephones. Like if you have a telephone, normally you can what you can do, both sides you can take it as a transmitter also, you can receiver also. Like your mobile phones, any mobile phone, it can act as a transmitter also, receiver also, because you can call or you can receive the call also. You can call to other person also, you can receive the call also. That is your mobile. At the receiver end also, it will be acting as transmitter and receiver. That is an example. This is an wireless communication. This is an wireless communication. Okay. And fax machines, same. Like you will be having a fax machine. Whatever the data you want to transfer, simply put at the transmitter end, at the receiver end, you will get it as a at the destination, you will get the information. In the same way, same fax machine can transmit the data from the destination end also. And handled CD radios, CB radios, and cell phones, computer modems, all those things come under your transceiver.